Good afternoon, everyone. So, how to prepare for US National Chemistry Olympiad? With Momentum Learning, we are offering for the fall semester US National Chemistry Olympiad prep for the local one. So, I just want to differentiate that. We'll talk about the local and national level and then international level later on. My name is Guvanch Murat Paitako. I have done my doctorate in computational chemistry. I taught so many years, more than 10 years, AP chemistry. I have prepared my country's International Chemistry Olympiad team in between 2006 and 2010. And my team students won bronze, silver, and gold medals in International Chemistry Olympiad. Last year, I started with Momentum, preparing for the local Olympiad. So what is this US National Chemistry Olympiad? It has three competition levels. First one is a local one. Local one is done in Houston, Greater Houston area. And the University of Houston is a professor from University of Houston is responsible for doing the local competitions. Your high school teacher might be registering the students for the local Olympiads. Starting last year, I believe the ACS started doing it even if the school or the teacher is not offering to register you, you can register yourself for the local Olympiad. Okay, so top performers at the local level advance to National Chemistry Olympiad exam. So it's about 1,000 students. Local one, entire US, around 16,000 students are taking each year. And among those 16,000, 1,000 will be advanced to the National Chemistry Olympiad. Among those National Chemistry Olympiad, 1,000, 20 of them will be selected for the study camp. And by the way, ACS, American Chemical Society, is sponsoring those camps and the local exams as well, and International Chemistry Olympiad exam as well. On their website, you can see previously released local exams, national exams. Some of them have solutions even there as well. So among those top 20 from National Chemistry exam, they undergo rigorous training. After that, only 4 of them will be advanced to the International Chemistry Olympiad. So no matter how big the country is or how small the country is, only 4 students from each country can advance to the International Chemistry Olympiad. We talked about timeline. This is for the last year. Next year also will be similar. So the deadline for the registration is January 19. It says somewhere this upcoming year, it will be similar that date as well. And local exams are taking place in March. And national exam is in April. June, there is a study camp, and then usually in July, International Chemistry Olympiad taking place every year in different host countries. 2 ways, as I said before, either your high school chemistry teacher registers you to the competition, or you can nominate yourself as well. That has started only last year, I believe. But still, there is a contact information coordinator, local competition coordinator. As I said, he's a professor at University of Houston. And sometimes they say so local chapter decides how it is done, registration. So I strongly recommend you to contact him if you can register by yourself. So last year when we asked, he was preferring to register with the school teacher. But what if your teacher is not registering you to the Chemistry Olympiad? Then communicate with them. We talked about already local Chemistry Olympiad exam. That's the first step. With the fall boot camp, we are preparing for the local Chemistry Olympiad exam. that will be foundation for the National Chemistry Olympiad as well, exam as well. But there is a lab portion is lacking, experiment option portion is lacking there. And then we are only preparing you for the multiple choice part. There is also another part is lacking for the National Chemistry Olympiad exam, that is written part. There are rules and eligibility criteria for the U.S. National Chemistry Olympiad exams. Students must be either a U.S. citizen or permanent resident green card holder. Students needs to be a high school students, and they should not be graduating no earlier than the 1st May of the year in which they participate in competition. So you should not be graduating May 1st next year. That means there is also age restriction as well, under 20. Okay, and another thing is some schools, their teachers prepare specifically for the local and national chemistry Olympiads. In order to be fair, they are restricting 2 students per high school. So there is a chance that you can be advanced to the national chemistry exam as well. So what's the thing? What I mean, when winners of any medal in international chemistry Olympiad, usually most of the even very prestigious like Ivy League universities, that medal is enough to get you in those colleges. So that's the I know from me, one of my students got into MIT because of that medal he won in International Chemistry Olympiad. Even if you are eligible, even if you won, there are not only chemistry, there is other subjects. International Olympiad is taking place, physics, math, and biology. You can be eligible for both of them, but they are restricting you because their camp that for 20 students, they are happening at the same time. That's why you cannot be attending both of them, so you have to pick one. All right, what are the topics for the local level? So I will be focusing on local level only, but I will give you some information about the National Chemistry Olympiad as well. So these are the 10 units we have, and for each unit, there will be a 10 question. So first 10 question is on stoichiometry and solutions topics. Next 10 will be descriptive and laboratory related, experiment related questions, and so on. So there will be 6 questions per each unit. That means total 10 units, 60 multiple choice questions you will have in local chemistry Olympiad. And time is provided, that's 110 minutes. All right. So what's the difference between local and national? I kind of talked about this. There will be, again, 60 multiple choice questions, but you will have not 110 minutes. This time you will have 90 minutes. And then there is a part 2 as well. That's a written question, open-ended questions. And then part 3 is you will be doing lab. You will be conducting experiment as well. All right, so once you, as I said, around 16,000 participants are each year take that local exam, and then around 1,000 of them will be advanced to the national. And students can, top 100 students get the honors certificate, and then high honors will be 50 students. So actually, it needs to go from top. So top 20 will be advanced to the study camp, and then among those 24 will be advancing to the International Chemistry Olympiad. And after that top 20, 50 students will be high honor, and then after that 50 as well, another 100 students will get a honors degree certificates. So what is requirement for US National Chemistry Olympiad? The topics are hard, but it is doable. I have analyzed past maybe 10 years. So a similar type of questions they are asking each and every year. That's why we can cover those topics in a short time. Otherwise, it will be taking a long time to cover all the topics and so on. So we are requiring you to have at least pre-AP chemistry knowledge, because there is no time to cover all the pre-AP topics within that time period that we have for the bootcamp. AP chemistry will be much better if you have, because most of the topics are approximately 90% of the topics will be covered in AP chemistry. Therefore, you will be in very good shape to start with US National Chemistry Olympiad if you have completed AP chemistry. But even if you have not completed AP chemistry, pre-AP chemistry is also fine. But you need to put a little bit more effort to catch up. What it looks like, how will it look like while I'm teaching? I will be selecting different questions among each topic, and then before I'm attempting those questions, I'll be teaching, giving some background about those units, and then we will be solving those questions together. What you need to know. So it's kind of shortcut. We are not going, as I said, we are not going into details about each unit. There is no time for that. Within that 2 hours, I need to complete the entire unit, sometimes 2 units. So that's why. But we will be solving previously released questions, and you will have an idea what type of questions will be there. So you will be confident. If you practice, we will be assigning you a homework every week, so that if you are struggling with any of those questions, you can contact me, and then I will be going over those questions next class, so that you will be prepared for sure. So there is no specific textbook, but what we recommend is this Zumdal and Zumdal AP Chemistry textbook. But any textbook, even online, LibreText is also fine. Our bootcamp for the fall semester will be we'll start in September until November 24th. And then every Sunday it will take place for 2 hours, 4 to 6 p.m. So in addition to just chemistry, there is also math. You need to have a minimum algebra 2, preferably pre-calculus level math. There is a lot math as is going on as well. If you have any questions, please contact us. Our office hours are given. If you want a faster response, please email us. So first one. 1 gram sample of which compound will produce the greatest amount of carbon dioxide after complete combustion with excess oxygen? So this is the first topic related, stoichiometry. Let's start with CH4. When you burn CH4 with oxygen, you are getting carbon dioxide and water. And if you burn the second one, C3, H6, again, you are getting carbon dioxide and water. You have to balance this chemical equation. So this is 1 CH4, 1 carbon. To make it equal on both sides, you need to put 1 as a coefficient as well, 1-to-1 ratio. How about here? 1 mole of C3H6 will be, if you burn it, 3 moles of carbon dioxide you are getting. So we have the mass, let's say 1 gram, that is given as a 1 gram mass. So you start with 1 gram, you convert them to moles. So that is the mole ratio we will use later on. 1 gram. If you divide the mass by molar mass of that compound, you are getting, molar mass has a unit, grams per mole. You should be getting the mole of that compound. In each cases, we have different molar masses as well. Once we have the mole number, we do the stoichiometry. Next one will be a stoichiometry, where in first one, 1 mole of CH4 is producing 1 mole of CO2. So mole is also amount. So you can just compare their moles. You don't have to convert it to grams, next one. So that's why the first one is in here. For example, molar mass of CH4 is carbon is 12, hydrogen is 1, and then we have 1 carbon, 4 hydrogen, so 12 plus 4 times 1, which is 16 grams per mole. So I need to divide by 16, and this is 1-to-1 ratio. What's the second one? Again, 1 gram I start with, but this time I need to find the molar mass of C3H6. So that is 3 times 12, carbon is 12, so 3 times 12 plus 6 times 1. So that is 36, and then this is 6, 42. So I need to divide by 42, and then, but the stoichiometry is different there. 1 mole of C3H, 1 mole of C3H6 will be forming 3 moles of carbon dioxide. So there is the pattern. So we have, we start with 1 mole, 1 grams, we divide by molar mass, and then do the stoichiometry. I need to compare, calculate all of them, and then compare. So 1/16, this is 1/16, first one. Second one will be 3/42. What will be the fourth one? So 6 times 12 plus 14 times 1. 72, and then 14, that is 86 grams. So that will be again 1/86 this time. And I need to have the 1 mole will be producing 6 moles of that. So I need to multiply by 6. And then last one will be C8, H18. That's why 8 times 12 plus 18 times 1. So we do the math. 96 plus 18. 96 plus 18, that will be 114. So that one will be 1/114 times 8 this time. So I need to do these math. 1/6. I can quickly compare. Oh, no. So I need to do the math. So 3 and 42 actually divisible. That is 14, 1/14. This is 1/14. So that will be, this one will be smaller. So this is the highest amount so far. How about 8/16? 8/60, 86, sorry. 8/86, that will be 0.093. Sorry, this one's supposed to be 6/86. Sorry about that. 6/86, that is 0.06976. About 8/114, 8/114, that is 0.07017. So this is the highest, but 1/14, I need to check 1/14 as well. 1/14 is 0.0714. So they are very close. So this one is the one, the highest. 1/14 is the highest, so that corresponds to B. So since I'm explaining, it takes longer time. So if I was trying to solve this question, so you need to be very quick, analyze. You need to know what you are doing. You need to know, you should be able to do the balancing and these conversions really quickly. So it takes longer time, for example, for this question. Some questions might be taking less time. So let's do the second one. We have a rhenium consists of 2 stable isotopes, rhenium 185 one, and then rhenium 187 one. So this is average atomic mass question. Average atomic mass is given to us. what's the mole percent of rhenium in rhenium 185? Yeah. So average atomic mass is weighted percentages of each isotope. You are multiplying and adding them up. That's how you get it. So 185. Let's say we have only two isotopes here. 185 is X percent. So 185 times 8, X divided by 100 plus, let's say 187 is, then there is, if X percent is 185, then 187 will be 100% minus X, which is 100 minus X divided by 100. You should be getting average atomic mass. So that's the weighted average, 186.2. So we can figure out the X there, percentage of that 185. And let's quickly do that math. So 185X plus 18700 minus 187X. That should be equal to 18620. That's a math. We multiplied both sides by 100, and then I distributed that. That is negative 2x, 18700 minus 2x is equal to 18620. So that is AD is equal to 2x, x is equal to 40. So the x is 186, that's a 40% by mass. If their molar masses are very similar, 187 and 185, then if the mass percent is 40%, then mole percent will be also 40%, because how you convert from mass to mole? Mass divided by molar mass. So mass you are dividing by 185 in one case, the other one you are dividing by 187. They don't make that much difference. That's why it will be still closest to the 40. Mole percent is also will be also closest to 40%. Next type of question is 10-gram sample of soluble barium salt is treated with an excess of sodium sulfate to precipitate barium sulfate, 8.93 grams. Which barium salt is it? So barium +2, that is coming from the soluble barium salt, and you are precipitating with sulfate that is coming from sodium sulfate. So sodium is spectator ion, it's just staying there. But when sulfate from sodium combines with barium, what you're getting is a barium sulfate as a salt, insoluble salt, solid. They say 10 grams of barium salt. We don't know what salt it is. So if it is a barium X2, it will be most probably. If it's a first -1 charge, but if the X is -2 charge, that will be then barium X only. So we can figure out the molar mass if we know the mole number. But what we know is 8.93 grams of barium sulfate is formed. If I know the molar mass of barium sulfate, I can figure out the mass of that. So 8.93 grams of barium sulfate. I will do this is 233.4, that is grams per mole. That means 1 mole of barium sulfate is 233.4 grams. So I had to write this one below, 233.4 grams, so that grams can cancel out, 1 mole above. So by the way, this is a molar mass can be considered as conversion factor. I can convert from mole to mass, mass to mole. mass to mole. So in this case, I wanted to convert from mass to mole. So mass should be below from mass to a mole. So I need to divide that so that I can get the mole of barium plus 2. So let's quickly calculate that. 8.93 divided by 233.4. We are getting 0.0383 moles of so that's the mole number of barium sulfate, 0.0383 moles. This is 1-to-1 mole. 1 mole of barium sulfate is produced when 1 mole of barium plus 2. And in all it is salts, barium is 1-to-1, 1 moles. So actually, if you all the options here, 1 mole of barium chloride has a 1 mole of barium. Barium, whatever this salt is, that's also one hidden one there. We don't write ones in formulas. So all of them are 1-to-1, okay. But if I know the mass and if I know the mole of barium, that's the mole of the salt as well. That will be equal to, because it is 1-to-1. 1 mole of salt has 1 mole of barium. If I know the mass, 10.00 grams, and if I divide by the mole of that, which is 0.0 barium, or that's the same as salt's mole, then what? 0.0383 moles. Grams per mole is a molar mass. So I will be getting the molar mass of that salt. This is the mass of salt. This is the molar mass, a mole of salt. If I divide, the ratio will give me the molar mass. I will be calculating one of these molar masses. So that is 10 divided by answer 261.4 I got, but maybe rounding, so 261.3. Then that salt should be C, barium nitrate. Next type of question. So right now I'm just directly going through the solving the problem. During our practice hours, I'll be also introducing some background information, or I'll be also explaining the topic as well before I attempt the question. In the reaction of sodium cyanide with 1-brom butane in methanol solution, what's the principal role of the cyanide ion? So these are kind of cyanide, sodium cyanide. So sodium is there, cyanide is here. All sodium salts are soluble. Cyanide will be -1 charge then. With 1-brom butane, so 1-brom butane, you have a bromine in a butane. That means CH2Br, CH2, it's a, and CH2CH3. This is the 1-brom butane in methanol solution. It says, what's the principal role of cyanide? Cyanide will be, cyanide is a nucleophile. Cyanide is a nucleophile. What does nucleophile mean is, it likes the positively charged place there. So when bromine is there, this is slightly, bromine is more electronegative, slightly negative charge, and the entire thing will be only, this side will be slightly positive charged. The cyanide is seeking the positive charge there. So, and the nucleophile is nucleus. Nucleus is positively charged, so it is seeking the positive charge. That means so that it can replace bromine from there. So if it comes to the positive charge there, bromine can leave. That's the substitution reactions. 59, the amino acid lysine has the side chain R. Okay, R is this. A mutation of lysine to which amino acid is least likely to change the overall charge on the protein at pH 8. So this one is NH3. That part is the basic part, NH3. So NH3 is, sorry, NH2 is the derivative of NH3, and NH3 is a base. So anything that is changing the over there, that will be making the a mutation of lysine to which amino acid is least likely to change the overall charge of the protein at pH. Okay, so for this one, we need to figure out the amino acids have charges on them, and we need to memorize that for this one. Least likely to change the overall charge on the protein. Okay, I think I didn't prepare for this one. Sorry about that. But we will cover everything on our lessons. All the questions will be answered and explained. Is there any questions? Related to chemistry Olympiad. Okay, let me change the. Okay. Is there any questions? Related to the, how will it look like? The lecturing, solving questions. The format is we'll have 2-hour lessons, homework as well will be given weekly. And then the lectures will be recorded, and they are available 3 months after the last day of the bootcamp as well. It will be available after the last day of bootcamp. 3 more months it will be available. So there will be no chart. No. The amino acid lysine has the side chain R given. Okay. Mutation of lysine to which amino acid is least likely to change the overall charge on the protein. Okay. So that is why it could be A. So basicity will change pH 8. Equal to 8. So that is basic for sure. 59. Most probably it is A. So NH2, NH3. So they are all basic. When you have this one as well, that's also basic. But the rest of them, we don't have a basic thing. So 59 might be A. But as I said, I'm not very sure about that one right now. Any questions related to USNCO prep, local exam prep bootcamp? All right, if there is no question, we can end it here. But please feel free to ask questions if you have any. All right, then we can end it here. Thank you for attending. Okay, about how long is the pre-AP class? Is there enough time to take pre-AP, then take this course? As I said, we have only 2 hours, and then for each unit, actually some of them are 2 units combined. If you have noticed there, let me see. If you have, so stoichiometry / solutions, for example, that's actually a 2 unit. That is, I am trying to explain and then solve questions related to that in 2 hours. So that is kind of what I mean. If you don't have a pre-AP background there, you might easily get lost, what I mean. That's why I strongly recommend you to have a pre-AP background in order to at least pre-AP. So if it is AP, as I said before, it's even better. Before 9th grade, as I said, if you have taken pre-AP, if you have some chemistry background, then it is good. But otherwise, it will be hard. But I will be explaining everything about those question types and how to approach, how to solve them. In your, what I have done is, for example, for AP chemistry as well, we require pre-AP, so students have a pre-AP background. But what I have witnessed is one student, he didn't take the pre-AP. He was very willing to do it, actually. And then he just started with AP chemistry, and then he got 5 on the test as well. So it depends what I mean, how hard you want to work. You can make up those lost time, but you need to put extra effort on that if you don't have a pre-AP background. It is doable, but we recommend you to have a pre-AP background. Any other questions? If you have taken AP chemistry, for example, you already have background about stoichiometry solutions, descriptive laboratory states of matter, thermodynamics, kinetics, equilibrium, oxidation and reduction, the atomic structure and periodicity as well. And then the only missing part will be organic and biochemistry. So we don't go into details in AP chemistry as well, organic and biochemistry. So other than that, everything will be what I mean. If you have taken AP chemistry before, then you already know those topics. Then it will be much, much easier. So depending on high school, some high schools offer at 9th grade chemistry, some high schools 10th grade. So that's why it's kind of what I mean. I don't know, but some chemistry background is needed. Otherwise, you can easily get lost. What I mean, within that 2 hours, I assume that you know the basics. That's why it goes kind of fast. What I mean. Please feel free to write on a chat box as well, or you can unmute yourself and ask freely. If you have questions any type, let me know. And also when we offer on in Momentum pre-AP curriculum as well. So for example, this fall semester, we are offering pre-AP chemistry A only, which means half of the pre-AP curriculum. And second semester, during the springtime, we are offering pre-AP B. So they are kind of different. So that's why just pre-AP A is also not enough, what I mean. And pre-AP, we don't, so pre-AP topics are, there is no kinetics, for example, in pre-AP topics. There is no equilibrium in pre-AP topics. That's why some units will be missing, even though you completed pre-AP as well. As I said, there is only 6 questions for each unit. Once you master those 6 type of questions, you should be good actually, what I mean. And I will be teaching whatever those 6 questions for each unit. I'll be practicing with you over and over, similar type of questions, but they are different. So 60 questions, if you study hard, you should be able to do it without background as well. But it will be hard, as I said, what I mean. Even if you take this course, if you are not 9th grade, if you are not in high school, I believe you are not eligible for the national one. So even local one, maybe they may reject. So high school students are eligible for this. So before 9th grade, you may not be able to take the test because it is intended for 9th grade, high school. All right, if there is no more questions, we can end it here. Thank you all for joining. Hopefully that was helpful. Thank you.